In this demo, we're going to investigate troubleshooting commands available in Cisco iOS to help diagnose WAN connectivity problems. In the exhibit, you see that we have two routers, router A and router B. They're both connected over a point-to-point WAN circuit using their serial interfaces. Both routers have been configured, but there remains a lack of connectivity. We cannot ping across the link. We need to diagnose why that is. Let's start with router A. We'll enter ping 192.168.1.2. That is the IP address on the other end of this connection. We can see that there is a connectivity problem between the two routers. Based on that, let's enter a few show commands to try to determine the root cause. We'll start by typing show interfaces and specifying the serial interface that we're using. So we'll add S000 to the show interfaces command and press enter. On top, we see serial 000 is up, but the line protocol is down. When you have an up-down situation, that usually means it's a layer 2 issue. That gives us a starting point. We can see it has an IP address of 192.168.1.1 assigned. Also, we see that the encapsulation is set to PPP. This is all good information. It's worth noting, however, that PPP is not the default encapsulation type on serial interfaces. HDLC is the default. The down situation could be the result of HDLC running on the other end. It doesn't matter which one you choose as long as they're identical in their settings on both ends. That's something that we'll have to check on the other end to make sure that the encapsulations match. If we enter Show IP Interface Brief, we can see the same situation on the bottom. It's in an up-down state. There's definitely something wrong here. It could be on router A. It could be on the remote end. We don't have enough information at this point to be sure. A good next step is to use a show run on the local router and look at the serial interface again. We can see the same IP address and mask we saw earlier and encapsulation PPP. We knew we were using that. A new piece of information is this PPP authentication is CHAP. So, this interface has been configured to authenticate with the other end. Again, not a problem, actually a good thing, but we need to verify the same has been configured on the other end. Maybe now is a good time to switch over to router B and look at its configuration. We'll resume a telnet connection that we had with router B. We'll execute that same command again, show run int S000. Both configurations are on screen now, so we can do a side-by-side comparison. That will be helpful. We can see the IP address and the mask. Just focusing on that, they do look like they are compatible, 1.1 and 1.2, with a common mask. There's no reason from an IP standpoint that they should not be able to communicate. They're both configured for PPP as well as authentication CHAP. We can also see a clock rate has been set on the router B serial port. That tells us that it's the DCE end, the WAN connection. Nothing jumps out on screen as being a problem. Next, we'll broaden the show command. We'll enter show run and see what else might be in the config. We'll go to the next page. Now we can see a username command here. This is required for PPP authentication CHAP. Username router A is the device on the other end of this serial connection, the host name of that device. So that looks accurate. Then password secret. So secret is the shared string that must match on both ends of this connection. Let's make a note of that and verify that the same is configured on the other end. Let's return to router A and enter that same show command, show run. Page down once, twice, and there's the username command. It looks okay so far. Router B is the other end of this connection. But notice the password has been mistyped. In this case, we have an extra letter E in the word secret. These strings do not match. That's something we'll have to fix. That's an easy fix. Let's do that right now. Let's go back to the global config and re-execute the username command, being more careful this time to type it in correctly. There we go. We'll perform a shutdown of the port to reinitialize the authentication sequence, but prior to doing so, we'll enter a terminal monitor command. That will redirect console messages to this telnet connected session. Let's enter debug PPP authentication to activate a debug of PPP authentication. All right, now let's go back to that interface, enter shut, and wait for it to go down. We'll enter no shut to bring it back up. You should very quickly see a flood of authentication debug messages. On the very bottom, you can see that the status of the interface has been changed to up. This is what we're looking for, success messages on the bottom. If authentication was failing, as it was prior, you would see failure messages on the bottom here, indicating a password string mismatch. Because we're done debugging, we can turn that off by entering undebug all. Let's repeat a couple of these show commands. For example, IP interface brief. Well, that's better on the bottom. We now have an up-up state. So far, it looks as if the password mismatch was the cause of the problem we were having. Another cause of up-down could be an encapsulation mismatch. Once again, if we had a PPP on one end and HDLC on the other, that would also result in an up-down state. Let's enter ping 192.168.1.2 to get across the link and see if we fixed everything there. It works. Yes, we fixed everything there. The reason we used ping is that even though we are in an up-up state, it does not mean we don't still have a problem above layer 2. That's why we looked at the IP addresses and verified that they are compatible. Even though layer 2 might be in good shape, you could still have two IP addresses that simply don't exist on the same subnet and thus still could not communicate. That's why we troubleshoot from the bottom up, which means starting with layer 1. Are the devices connected? Is there a cable unplugged? Are the devices connected properly? Are the pinouts correct? If the cabling looks good, then we move to layer 2. Layer 2 in this demo included the encapsulation types and the authentication process. Once those were fixed, layer 3 required only IP compatibility for things to start working. That's it for this demo. In this demo, we performed troubleshooting on WAN circuits.